So, imagine someday in future you planned a trip to Mars on a starship, and after reaching there, much to your shock, you find that your rocket is out of oxygen fuel and you just have some days of oxygen left. So, what do you do on a lifeless planet whose atmosphere is nothing but hugely dominated by carbon dioxide, and you need oxygen for you to survive and also for the rocket to get back to home? The dominant gas on Mars is carbon dioxide, sad for you and your rocket, right? So, what will you do? This is Lighted Sky. Let's learn about MOXIE. MOXIE is a technology demonstration experiment which is now on board the Perseverance rover doing its thing. So, what is this MOXIE doing there, and how does it work, and what could it mean to us? Let's answer all those questions one by one. What is MOXIE? MOXIE, the acronym for Mars Oxygen In Situ Resource Utilization Experiment, is a technology which is being tested on Mars. It is a tiny box of size 24 x 24 x 31 centimeters and weighs around 15 kg, which is investigating the production of oxygen on Mars. Launched aboard the Perseverance rover in July 2020. Its sole mission is to produce oxygen, not just producing oxygen, but also meet some criteria. Like its objective is to produce oxygen of at least 98% purity at a rate of 6 to 10 grams per hour, and do this for 10 times. So the device can be tested in a range of times of the day, including at night and in most environmental conditions, including during a dust storm. Homemade liquid oxygen on Mars could supply more than 3/4 of the propellant humans need for exploration on the red planet. And it's like a tree which inhales carbon dioxide and exhales oxygen. So, is it the first time of oxygen production experiment on Mars? To know that, let's see the next question. History of production of oxygen on Mars. The production of oxygen on Mars is not a new idea. Earlier, back in the year 2001, another instrument was built named as MIP, which stands for Mars In Situ Propellant Production Precursor, designed and built to be set up on the Mars Surveyor 2001 lander. MIP was to demonstrate the in situ propellant production ISPP on a laboratory scale using electrolysis of carbon dioxide to produce oxygen. But the vehicle on which the instrument was to travel to Mars, which is the Mars Surveyor 2001 lander, the mission was cancelled due to the failure of the Mars Polar Lander mission. The reason for the failure was that the lander failed to re-establish communication with Earth. A post-mortem analysis determined the most likely cause of the mishap was premature termination of the engine firing prior to the lander touching the surface, causing it to strike the planet at a high velocity. So, Mars Surveyor 2001 lander was cancelled. That lander was used for the Phoenix mission in 2008. So, MOXIE instrument was designed and then sent on the NASA's Mars 2020 mission on the Perseverance rover, and the experiment was successful as MOXIE produced oxygen for the first time on April 20th, 2021. Before knowing about its current status and future developments, let's know how it works. How does it work? I don't want to get into the chemistry part, but the theory is that Mars is a planet with a thin blanket of atmosphere, not as same as that of Earth. Mars atmosphere is made up of carbon dioxide, which is a principal constituent. Next, we find nitrogen, argon, oxygen, and carbon monoxide. Also, trace amounts of the noble gases are also present. Additional minor and highly variable constituents include water vapor, ozone, and dust particles. Therefore, the instrument accumulates, compresses, and heats these Martian atmospheric gases. This is done with a HEPA filter, a high-efficiency particulate absorbing filter, which contains a mat of randomly arranged fibers. Then a scroll compressor and heaters alongside insulation work. This then splits the carbon dioxide molecules to oxygen and carbon monoxide using solid oxide electrolysis, where the oxygen atoms combine to form gaseous oxygen. The reaction is as shown. The reaction requires a temperature of around 800 degrees Celsius, hence the whole instrument is covered with a heat-tolerant material and features a thin gold coating to keep potentially damaging heat from radiating outwards into Perseverance body. So, after we know how it works, let's see what is its current status. As said earlier, on 20th April this year, the instrument produced oxygen from the Martian carbon dioxide by the process we discussed. The experiment produced 5.37 grams per hour of oxygen, equivalent to what an astronaut on Mars would need to breathe for roughly 10 minutes. MOXIE is designed to safely generate up to 10 grams per hour of oxygen, with theoretical production limited to 12 grams per hour of oxygen due to the limited capacity of the 4 ampere flight power supply. This experiment is a collaboration between the Massachusetts Institute of Technology (MIT), the Haystack Observatory, the NASA or Caltech Jet Propulsion Laboratory, and other institutions. This brings us to the last question: what is the future of the technology and other uses? With the current experiment, which produced oxygen of 5 grams, kilograms, and this would give an astronaut about 10 minutes of oxygen supply. This is not enough, and more efficient and scaled up model can be developed so that it can also fuel up the rockets and for use in human missions to other planets to provide breathable oxygen, oxidizer and propellant. Water may also be produced by combining the produced oxygen with hydrogen. Presently, MOXIE is planned to isolate oxygen a further 9 more times over the course of approximately 2 Earth years or 1 Martian year in 3 stages. The first stage will further investigate the oxygen production, the second to test the instrument in a variety of times of day, seasons and atmospheric conditions, and the third to produce oxygen at different temperatures and alter the mode of operation to investigate differences in production. If the experiment works efficiently, they could build an instrument which will be approximately 200 times larger than the present size MOXIE based instrument on the planet, along with a power plant capable of generating 25 to 30 kilowatts. Over the course of approximately 1 Earth year, this system would produce oxygen at a rate of at least 2 kilograms per hour in support of a human mission sometime in 2030s. The stored oxygen could be used for life support, but the primary need is for an oxidizer for a Mars ascent vehicle. The carbon monoxide, a byproduct of the reaction, may be collected and used as a low-grade fuel or reacted with water to form methane for use as primary fuel. As an alternate use, an oxygen generation system could fill a small tank to support a sample return mission. The oxygen could also be combined with hydrogen to form water. So, what's the conclusion? MOXIE is at present a technology demonstration experiment which is promising some positive results. This is necessary as we cannot take everything back from Earth to the space exploration and beyond. We will have to use the available resources and make them useful. This generation of resources can not only bring down the cost of space travel but also bring in a technological advancement for all the humanity. With the current results, the goal of humans visiting Mars is taking its shape. Hence, MOXIE is not just producing oxygen for us but also for the rocket propellants which depend on oxygen. Future explorers will depend on producing propellant on Mars to make the trip to home. So at start, I asked you to imagine going to Mars. Please come back to Earth now and watch my other videos. That's it from the video about MOXIE, and if you are new to the channel, please subscribe and like the video and also share it with your friends and family. That's it. Till next time, take care and be safe. Thank you. And next, watch my video about upcoming missions of this year 2021.